Hello students. In this session we will talk about one of the best provision in the construction pavement, and that is drainage layer. This is the general construction of road pavement, wherein you can see here a under drain which is provided at the subbase course, that is a kind of a granular course. Previously we have discussed on the construction of subbase and base course. Today we will see the construction of drainage layer. There are different methods to provide the drainage layer. So before that, let's have a general introduction on the drainage layer. Now, the, during the rains, the part of the rainwater that flows on the surface and the part of it percolates through the soil mass as a gravitational water until it reaches the groundwater below the water table. So basically this says that when the monsoon occurs, when the rain occurs, the water particles, the rainwater percolates in the pavement layers through the soil mass as a kind of gravitational water, and it reaches to the subgrade soil, we can say. Now, so if it reaches to the subgrade soil, it will lose the subgrade soil, and that will create a damage, that will create a problem in the construction of pavement. So that we need to remove, and or else we can say we have to divert this water. So the drainage is required in the construction of the pavement. Mainly this drainage can be provided as a surface drainage and the subsurface drainage as shown on the screen. So basically we have these two methods where we can provide the drainage layer. First on the surface, and second in the pavement layers, that is subsurface. Let's these are the three and two methods, sub methods for the drainage layer. The first is by longitudinal side drains, and second is by providing catch basins or else the inlet in the urban areas. So that will be the surface drainage, which generally provided near the pavement construction. And second is the subsurface drainage, that is these methods are provided in the construction of the pavement. Now that is by lowering the water table, or else by controlling the seepage flow and the capillary water. Let's discuss thorough in these methods. Let's discuss the first, that was the method of surface drainage, and in that the first method is by the longitudinal side drains. So by providing the longitudinal side drains, we can provide it that side drains for the road in embankment. So what this method says, when the road is constructed in embankment and if it is necessary to provide the side drains on one side or the both sides, such side drains should be constructed at least 2 meters away from the bottom edge of the embankment. Here in the figure we can see here this probably the embankment edge, bottom edge, and from here at least 2 meters away we can provide the side drain. Now the depth of the side drain is kept around 1 to 1.5 meter just to prevent the entry of drain water into the embankments. As here mentioned that the depth of this drain should be around 1 to 1.5 meter. So this is the method wherein the side drains are provided for a road in embankment. the next method, that is side drains for road in cutting. Now, when road is constructed in cutting portion, the side drains are provided on either side of the road. The drain should not overflow in any circumstances. The closed roads or the closed side of the drains are preferred, as open and the deep side drains are dangerous where space is limited. Also, sometimes this open and deep side drains may be dangerous because of it cause sometimes the accidents. So for such cases, the closed drains are more preferable. In such cases, the covered drains of drainage trenches properly filled with the layers of coarse sand and the gravel that may be used. Coarser gravel layers are provided at the bottom of the drain. Here you can see in the figure that this is the original embankment and this pavement is constructed in the cutting area. So at that moment the closed type of drains are preferred, so that here at the two sides it can be applied for either two sides and single sides. So here the side drains are provided both the sides, and for such kind of pattern a coarse gravel layers are provided at the bottom of the drains. So this is the method of subsurface drainage by providing the side drains for a road in cutting. Next is subsurface drainage. The previous one was by providing side drainage, and this surface drainage pattern is by providing catch basins or the inlets in the urban areas. So let's discuss on the surface drainage with the catch basins. In urban roads, because of the limitation of land width and also due to the presence of footpaths, it is necessary to provide the underground longitudinal drains. The catch basins are a structure like a camber that is constructed on a severe line. The water from pavement surface is collected in the catch basins and it is discharged to the severe drain. So probably these catch basins are connected with the severe drainage line. Now the catch basin is provided with grating to prevent the entry of this rubbish into the drainage system. These gratings are nothing but the kind of layer which work as a filter in this catch basin, so that such kind of rubbish entry can be prohibited, can be restricted. Now the impurities in the water are collected at the bottom of the catch basin, which is to be cleaned regular basis. A hood is provided in the catch basin to prevent the entry of severe gas into the catch basins. The next is inlets. Yes, this is the inlets. Now what inlets is? Inlet is a structure that is constructed along the edge of the urban road to discharge rainwater into the storm water sewer. The inlets is a kind of a concrete box with a grating either at the top or on the sides. If grading is horizontal, it is called as the horizontal inlet, and if the grading is vertical, that is called as a vertical inlet, or we can say it's a curb inlet. Here in the figure we can see this is the vertical grading, so this will this will called as a curb inlet, or we can say the vertical inlet, and here this grading is provided horizontally, so we can say this is the horizontal inlet. The function of inlet is also same as the catch basins. It also allow water to come, and here the gradings are provided at the opening so that that debris can be restricted over here also. And this storm water is to be connected with the severe line, so this water will directly go to the severe line. So this is the function of inlets and catch basins. So this is all about the surface drainage. Now next topic is the subsurface drainage. How we can provide the subsurface drainage? Let's see. The method of subsurface drainage. Before going for the methods, let's discuss something, or let's brief something about the subsurface drainage. Subsurface drainage, that is provided for the removal or the diversion of excess soil water from the subgrade. Now the subgrade drainage or subsurface drainage is necessary because of the when the road is in cutting and the water seeping from the sides, at that moment you must need to provide the subsurface drainage. Also, when the road is near the foot of hill and is likely to be damaged by water down to the hill, at that moment subsurface is must. Also, when the road is passing through the plain area and the water is likely to be accumulated on the sides, where the water rises up to the subgrade by the capillary action, at that moment the subsurface drainage is must to provide to prevent the entry of the capillary water into the pavement layers. Also, where subgrade soil is affected by the drain passing near the road, at that moment the subsurface drainage is useful for the removal of this unnecessary water. So now let's discuss on the various methods we are using for providing the subsurface drainage. The first method is by lowering of water table. Okay. Now what is lowering the water table? How we can provide the subsurface drainage? Now the highest level of a water table should be fairly below the level of subgrade. In order to that, the subgrade and the pavement layers are not subjected to excessive moisture. If you are providing subsurface drainage by lowering the water table, the highest water level should be fairly below the level of subgrade. Now, the water table should be kept at least 1 to 1.2 meter below the subgrade. In places where the water table is high, the best remedy is to take the road formulation on embankment of the height not less than 1 to 1.2 meter. So, when the formation is to be at or below the general ground level, it would be necessary to lower the water table. So this is how the lowering water table affect the subsurface drainage. If the soil is relatively permeable, it may be possible to lower the high water table by construction of longitudinal drainage trenches, which is already shown in the figure. Here we have the longitudinal trenches or the drain pipes, we can see, with the filter sand. Okay, now the top of the trenches is covered with clay seal, and the depth of the trench would be depend on the required lowering water table, the distance between the drainage trenches, and the type of soil. The next we can say, if the soil is relatively less permeable, so at that time what? So at that moment, lowering of the groundwater table may not be adequate at the center of the pavement. Hence, in addition, the transverse drain maybe have to be provided in order to effectively drain off the water and thus the lower the water table. As here in the figure we can see these are the transverse drain provided. This is the plan for that. So these are the additional longitudinal drains are provided, or the transverse drains are provided with the longitudinal drain, so that that water table can come to the lower stage. Here the transverse drains are provided at the spacing of 6 to 20 meter and at the slope of 1:5 from the center of the edge of the road. The next is subsurface drainage for the controlling seepage flow. Okay, now here in this method, when the general ground as well as the impervious strata below are sloping, the seepage flow is likely to exist, and if the seepage zone is at the depth less than 0.6 to 0.9 meter from the subgrade, the longitudinal pipe drains in trench filled with filter material and the clay seal may be constructed to intercept the seepage flow. The figure shows the method by which the seepage line can be lowered to the desired depth. Now next is subsurface drainage by controlling the capillary water. Well, in this method, instead of lowering the water table, the capillary rise is arrested by the following methods, and these methods are by providing the granular material with the suitable thickness, and the second method the providing capillary cutoff. So let's discuss that methods. The first is by providing the granular material. In this method, a layer of granular material with a suitable thickness is provided during the construction of the embankment. As shown in figure, this is the granular material layer. Now, this provided between the subgrade and the highest level of the subsurface water table. Now, the thickness of the granular capillary that cutoff layer should be sufficiently higher than the anticipated capillary rise, that is within the granular layer, so that the capillary water cannot rise above the cutoff layer. So this is how we prevent the water from by using the granular material. The next method is by providing the capillary cutoff. Well, in this method, we are providing the capillary cutoff, and that is by inserting an impermeable layer or a bituminous layer in the place of the granular banquet. Like this. Here you can see in the previous one we have provided the granular material, and now in the second method, instead of using this granular material, we are providing an impermeable layer, so that what will happen, the water will come but it will not get into the base layer or else its upper surface layer. So you will not face any waterlogging from the pavement surface, and because of this provision, you can prevent the road to be get damaged. I hope you will you get the thorough information about the drainage layer. Thank you.